Welcome to NSX Advanced Load Balancer Operation Workshop video series. My name is Sean, and today we're going to continue to talk about understanding NSX ALB virtual services. In today's video, we're going to focus on pools. So we'll cover health monitors, load balancer algorithms, persistence, servers, and SSL to backend servers. So let's jump right into the demo. Here we have our controller. I jumped to the pools tab because we're going to focus on pools. So let's create a new pool. So as usual, you need a pool name. So this will be our demo pool. We need a server port. Now all my applications have specific ports. So in this case, maybe I'll make the port 380. So this is a port I know that works, 30,080. We have graceful disable timeout. So if you disable any of your servers, it'll wait 1 minute to slowly time out those connections. So new connections will move to servers that are still up, but it won't remove existing connections until this 1 minute time to hopefully move those existing connections over to the other servers. We also have auto scale policy and auto scale launch config. So these two work together. So you configure an auto scale policy that will act on an alert, and the launch config will act on that alert. So it'll configure more pool members. This is more of a dynamic auto scale for your servers in the pool. So this is a very custom use case and is available if you're looking to auto scale it. There's some KBs about it for clouds like such as Azure, where you can configure custom auto scale out policies in the Azure cloud and have an alert that will trigger something on the controller itself. So this is a good use case if you have the ability to auto scale in your cloud environment. Now, we also have persistence here. So this is where you would define a persistence profile. What a persistence profile is an ability to stick connections to a particular server. And there's multiple ways to do this. So if I drop down this menu, we have a bunch of system prepackaged persistence profiles. So let's just click create and see what we have. So when we click create, the first one that comes up is client IP address. So we'll persist our client IP to a particular backend server. And it comes with a persistence timeout. So this persistence timeout will keep that client IP bound to that backend server until this timeout is reached. Okay. Now another persistence profile might be app cookie. For app cookie, we can specify an app cookie name, and this will be a cookie that's provided from the backend server. So that based on that app cookie, we'll build a table on the service engine, and that table will map this particular app cookie from that backend server to the particular client that's making the connection. And it also has a persistence timeout of 20 minutes. So if the client doesn't make a connection with that cookie for 20 minutes, we'll remove it from the table. Another one is our custom HTTP header. So based on an HTTP header, we can persist to a backend server. GSLB site is specific to GSLB. So we'll push that aside for now. Maybe in a future series, we'll cover GSLB and their use cases. But in this series, we're going to focus on just the pool specific persistence profiles. Now we have HTTP cookie. So what an HTTP cookie is we will generate a cookie, and inside that cookie will be our backend server binding. So when a client makes subsequent requests and passes this cookie along, we know which backend server to keep that client attached to. So the client will keep sticking to the specific server that's inside of the cookie details. And here we have a persistence timeout. This will just have a timeout for that cookie as the cookie becomes more stale. And we can enable always send or just leave it as default, which is not enabled. And then we have our TLS persistence. So this will use the TLS ticket ID for that persistence. Now this requires HTTPS as it's a TLS persistence profile. Perfect. So let's discard those changes and move on to the next one. So we also have load balance. Load balance is the load balancer algorithms that are used for when the client connection comes in. So the default is least connections. So if we have, say, 3 pool members, 2 of those pool members currently have 5 connections, while the third pool member has 0 connections. Well, we'll send the next connection coming in to that pool that has no connections currently. So it's the server with the least amount of connections to it. We have consistent hash. So based off this value down here, we'll create a hash and send it to the backend pool based off that hash value. We have core affinity. So when we enable this, each CPU core uses a subset of servers and does a mapping between the servers and CPU cores. Fastest response is exactly as it sounds. So the server that has the quickest response based off the last client connection will use that server again. Fewest servers. So what we'll do here is the load balancer will try to use as few servers as possible. So it'll essentially monitor the current server capacity, and as that first server reaches capacity, it'll start using the second server. So it'll go from top to bottom and use servers until they reach specific capacity. Least load. So new connections sent to a server will use the lightest load. So if we have multiple connections to our backend servers, some of the responses might be heavier in data, like maybe it's a 2 megabyte picture. So it'll try to use the server that doesn't have a lot of data being transferred back to the client. And then round robin. So it just takes turns sending to the individual servers on the backend. So first it'll start with the top server, then it'll start with the second, and then third. So it'll distribute the traffic kind of evenly between the different backend servers. Now, the load balancing algorithm generally is for the initial connection to the load balancer. And if you don't have a persistence profile, yeah, load balancing algorithm will always be used. But if you have a persistence profile and say it's HTTP cookie, well, you won't use the load balancing algorithm anymore because you're going to try to persist to that server. You don't want to keep being distributed to servers based off round robin. You want to persist. So when persistence is involved, you'll always stick to a server. So that's good to keep in mind. We can configure a custom analytics profile. So when we talked about in the second video, analytics profile, I indicated we'll talk about it more in future content on troubleshooting. And I'm going to leave that to troubleshooting still, as it's very involved and there's a lot of different components that you can configure inside an analytics profile. So now we have health monitors. So health monitors, there's 2 different types. We have our passive health monitor. What the passive health monitor does, it won't actually remove servers from your pool. It'll instead monitor the server traffic, the server responses. And if it sees maybe something that's more of an anomaly, something that's not normal, it'll distribute the traffic slightly different between those backend servers just to try to auto-learn normal operations of these pool members. But it will never remove a pool member from the pool. So this is where the active health monitors come in place. So here we have our add active monitor. And we can select how many of these active monitors we want to be up before removing pool. If we want to add an active monitor, we'll click here and select a health monitor. So when we add an active health monitor, this is where when a pool, say we're talking HTTP on port 80, if that pool member stops talking HTTP on port 80, we'll remove it from the pool. We no longer want that pool member to get this traffic. So this is important to know, because if you only have passive health monitors enabled, all the pool members will indicate as up, even if one of the pool members is no longer talking on port 80. So keep that in mind when you're configuring your pools. Active health monitors are good to make sure that the pool members are actively serving the traffic they're intended to. So we have a bunch of pre-packaged health monitors on the controller. You can see them here. Let's just do a create and we'll walk through the different types. So the first one being ping. This will just do a ping against your backend server. So it'll check for successful checks twice. It'll wait for 2 failed checks. And these are the send intervals and receive timeout. Federated, again, is used for GSLB. All it's indicating is we'll replicate this health monitor to the remote site. But this is only for GSLB, so you don't have to worry about that one right now. Another health monitor we can configure is DNS. And since it's a DNS health monitor, we can put a specific request we're going to send to the DNS server in the backend. And here we can specify what we expect for a response. So this gives us everything we would need for a DNS health monitor. We send a specific request and we expect this response. If we don't get that response, let's remove that pool member from the pool. Next is external. So external is more of a custom health monitor. We have different packages installed on a service engine, and we can use different scripts such as Python to execute a custom health monitor to those backend servers. So an example might be an SQL command to the backend servers, or even an LDAP command to the backend servers. You can also specify specific parameters for your script and variables. And here you would put your health monitor port. So this is a custom script that you can create based on your use case. We also have an HTTP monitor. So this might be more familiar if you've configured these on other appliances in the past, as we have a health monitor port, which if it's HTTP, it might be 80. And then you can put your request data in here. So it could be a GET request, it could be a HEAD request. You could put a specific path here. HTTP 1.0 or 1.1. And then you could put response data, so what you expect as a response from that backend server. And you can make it very exact, the exact structure of the response, or can be less precise. Like you can just look into that request data on what you're expecting. And then we have our response codes. So what response codes are deemed valid from that backend server? And you have your 1x, 2x, 3x, 4x, 5x, or any. And here we can specify a maintenance response code. So if we see something, say it's 507, we can put in response data indicating that this is actually a maintenance page. The next one is HTTPS. So most of the fields are the same as what we saw in the previous health monitor. The main one is SSL attributes. So when we click this, we can actually put some SSL attributes for this health monitor. We can put the SNI server name. So if we want a specific host header for that SNI communication, we can add SSL profile. So if there's a profile type and remember, SSL profile is the different ciphers we support and different TLS and SSL versions. So if the backend is maybe using something less secure, we could enable that. Another one is PKI profile. Great. Ping, we covered. Another one being radius. So we have the ability to send a radius health monitor to the backend server. So if you have radius servers in the backend, we can use this health monitor and test that radius server is working. SIP is another one. So here are your options for the SIP health monitor. So based off your backend servers, you can modify your SIP response and your monitor transport, TCP or UDP. And then these two are more generic. So it's just going to be a TCP request. You can have request data. You can have response data. You can maybe even only expect a half open connection. Send a TCP connection. As long as it's half open, we're happy. All right. And similar with UDP. Something to note here, if you want to monitor on a different port than the pool port, you would add the pool port or the different port here. But if you just want to use the pool port, just leave it empty and it'll use what's configured for the server port. So exiting out of that, again, if you want to make sure your pool members are active, then add a health monitor and put your specific health monitor use case in there. So looking to the right here, we have lookup by server name. So this is just another option you can enable. Rewrite host header to server name. So we can rewrite the host header that's coming in from the client and use that server name. And enable real-time metrics. So it's disabled by default, but if you want real-time metrics, you can enable that. And at the bottom here, this one's a good one to know, because if your backend servers are talking HTTPS, we want to enable SSL to that backend. So without this enabled, we won't be able to talk SSL to those backend servers. So if you're re-encrypting to the backend, this is where you would do it. You would enable SSL, you would set the profile. So you could set a specific SSL profile, specific maybe TLS version or SSL version that backend server is expecting, as well as ciphers. And again, you have your PKI certificate validation and the client certificate itself. And here are some other fields. So you can do a common name check. You can include the TLS SNI server name, and you can rewrite host header to that SNI name. So if we put a host header name, we can rewrite the host header in the packet to that SNI name. So let's disable this. And that covers most of the fields here. We'll jump to the servers now. So we'll click next. And here we have our servers. So we can select servers based off IP address, range, or DNS name. We can also provide an IP group, and you can apply an IP group of these servers. So we can create a bunch of 1.1.1 and build our own IP group, and these would be the different servers for this pool. And you manage it all here. So if you have multiple pools using the same servers, maybe you would use an IP group, so you just have to update the IP group instead of the pool itself. But I'm going to use IP address range, and I'm going to do it the same way I've been doing it so far. So I'm going to select servers by name, and I'm going to use the VMware Cloud Connector integration, where auto learns the VMs in that vCenter server. I'm going to keep using the same servers we've been using in previous videos. Perfect. So we can enable HTTP2. If you have that use case, I just recommend reading the KB and learning more about the HTTP2 options you need to enable. But for a pool, to enable it, it would be here. Along with this, so we have our server name, we have our IP address, and we have our port. It's set to inherit, but if I want to put a custom port, I could put 30,443. This is a different port that my pool or one of my pool members is listening on. Now ratio, it's just to distribute the traffic, a way to distribute the traffic between the pool members. So if you kind of want to weigh your pool members, you can do that here. You can put custom headers for your pool, and you can rewrite the host header if you click this box. So those are the options available to you. Now, if you didn't select servers by network, there's no reason you can't just configure a server like this, and you could specify a port of your choosing. Now, this isn't a server that will work, and this isn't a port that it will be listening on. But to prove my example, this is what it would look like when you add that server. So jumping to the next screen, these are some more advanced options you can enable for your pool. So you can configure your request queuing. So it's disabled by default, but if you want a queue request, you can have this enabled. And then from there, you could specify your queue length. But I'm going to leave it disabled. Pool failure settings. So this is what will happen when your pool fails. We can specify a specific action to occur. Close connection is default, but you can have a local response. A local response being you can put a default page and use a specific status code. Another option is your redirect. So you can redirect to a different site. Maybe you have a backup site, so you can redirect to that location. I'll leave it at close connection. We can also modify the placement settings. So remember, in a dual arm scenario for placement, you have your front end interface and your back end interface. We can control where we're going to place that back end interface by adding a server network. Here's some connection settings. So we can idle out the connection, and after this time, we can we can manage the connection life timeout. We can specify how many times the connections reused. This is more for connection multiplexing, because in connection multiplexing, we're going to reuse those backend server connections. So we can indicate how many times we're going to reuse a specific server connection. And we can put the max cache connections per server. Another option is we can disable the port translate that the client's making to our virtual service. So we can say, don't do a port translation. Leave it to the same port that client's hitting on the front end. We can also specify default server timeouts. So when to timeout that backend server connection, we can program in a connection ramp up time. So if a new server just comes in, we can say, ramp up the server over 10 seconds. So new connections will slowly start building up on this new server. And we can put max connections to a server, 0 being the default, so there is no max. So maybe you're using something in the backend, and that backend has a max connections per server. Well, you can control that here as well. So HTTP server redirect. Let's enable this and see what we get. So we can specify an HTTP response code from a backend server and try to connect to a different server based on that response code. So if we get a 400 response code, we can try to reselect a different server and try to get a 200 instead. So that's the configuration for a pool. If we click next and save, we get our server created, but it's not bound to anything, so it becomes unused. Until this is bound to a virtual service and gets placed, we will not get a green box or an indication that it is up or not. That's the end of my pool demo. I hope that was informative, and if you want to have a play for yourself, again, we have the hands-on labs for you to explore further. So thanks for joining me, and stay tuned for our next video.